Okay, in this video, we are learning about linear transformation. So we're starting on page 16. First, you have to understand what the parent function is. So the equation for the parent function is y equals x. You have seen this equation before. You may also see it as f of x equals x. Remember that y and f of x are the same thing. So even though all we see is letters in my parent function, you should know that the slope is 1 because anytime you don't see a number with x, there's a 1 there. You should also know that the y-intercept is 0. Again, there's nothing here, so it would be like a plus 0. Okay, so first thing we're going to do is we are going to graph this equation into decimals so that we can pull up the table. So y equals x, that's my parent function. I'm going to pull up the table. I'm going to copy those points onto my table. So from -2 all the way to 2 on the x's. And then for the y's, -2, -1, 0, 1, 2, the exact same numbers. Now, the reason that both x and y are the same thing is because I just have an x, right? I'm not multiplying nothing to it. I'm not adding nothing to it. So the number just stays the same. Okay, so now I'm going to take these points and plot them into the graph. So -2 with 2. -2 with -2. I missed my negative on that one. -1 with -1. 0, 0, 1, 1, 2, 2. As you can see, it's just going up 1 over 1, up 1 over 1, because my slope is just 1. So then we connect them with the straight line. And this is what we call the parent function. Okay. So this one says, why is the slope 1? Because it goes up 1 over 1, right? Rise is 1, run is 1. And then why is the y-intercept 0? Well, because that's where the line crosses the y-axis. Is where the line crosses the y-axis. Okay, so what we're doing today, we are going to be comparing lines to the parent function. So this is called the parent function. It's like the original function. Anytime we change the slope from a 1 or we change the y-intercept from a 0, it creates a different graph. And so we're going to be learning what happens to the graph whenever we change the slope and whenever we change the y-intercept. Okay, so for the sake of the video, we're going to skip page 17. We're going to go straight into the transformations on page 18. Okay, so page 18 says the parent function f of x is graphed on all the grids. On your papers, it's the one that is bolded. On my screen, it's the black line. It says identify the y-intercept for the new function g and describe the change from the parent function. So on this page, we're only going to be looking at changes to the y-intercept. So remember, my parent function is y equals x. The original y-intercept is 0. We're going to be seeing what happens when we change the 0 to another number. Okay, so as you can see, my slope for this parent or for the new function is 1. We're not changing the slope. We're only changing the y-intercept so that we can see what happens to the y-intercept. So the y-intercept for the blue line, we're working with the new line. The blue line is 2. You could see it on the graph. You could see it on the equation. My y-intercept is 2. And if you notice, the blue line is above the black line, which is the parent function, which means that it shifted the graph up by 2 units. The line shifted 2 units up. Okay, we're going to go straight down on the left side first of the page. I'm going to move on to the bottom. My y-intercept for the blue line and this one is 4. And so it's still above the line. It shifted it up 4 units. 4 units up. And then this last one here, now they changed the y-intercept to an 8. And so the same thing happened. It shifted the line 8 units up. So as you can see, the gap between the lines is getting bigger and bigger because it's getting shifted up higher. So on the bottom, it says what happens to the graph if we increase the y-intercept, which is what we did here, and it just keeps shifting the graph up and up, right? So it shifts the graph up when we increase it. Okay, let's go back to the top right side of the page. So now you notice my graph is not above the parent function anymore. The blue line is below it. And so it's at -2. The y-intercept is -2. That means it shifted the graph 2 units down. Now I don't put the negative on the 2 because down means negative, kind of. I'm just saying it shifted it down 2 units. Okay, now it's even further below the parent function. Now the y-intercept's at the -4. So my b is -4. It shifted the line 4 units down. Okay, same thing happens here. My parent function is at the 0. The new equation has the y-intercept at -8. So the line shifted 8 units down. Okay, so if you notice, all the ones on the right side had negatives, so it was shifting the unit or the graph down. So what happens when we decrease the y-intercept? It's going to shift the graph down. Okay, so changing the y-intercept moves the graph up. If we're adding a number to the y-intercept, it moves the graph down if we're subtracting a number to the y-intercept. Okay, so really, really easy what the y-intercept does. Okay, so now let's look at what happens if we change the slope. So on page 19, we're changing the slope. So my parent function, y equals x, the slope is 1, the y-intercept 0. Now we're keeping the y-intercept at 0, and we're changing the 1 with the x to different numbers to see what happens if we change the slope. Again, the parent function in your paper is the bolded line. On my screen is the black line. Okay, so now you can see both lines have the y-intercept at 0. That's not changing. B is going to stay 0 in all these graphs. We're changing the slope. So the slope is a number with x is 2. So if you notice, the graph, the blue line, is what we call steeper than the black line, than the parent function. The graph G is steeper by a factor of 2. Okay, so steeper is just like more inclined. Okay, next one, my graph has a slope, the blue line has a slope of 4. And so again, you can see the blue line is steeper or more inclined than the parent function. We say steeper by a factor of 4 because the slope is 4. And then the last one that I have here, the slope is 10. So you can see that the number's getting bigger and bigger, and the graph is getting steeper and steeper by a factor of 10. So the bigger your number for the slope is, the steeper the line is going to get. Steeper just means it's more inclined. It's like kind of looking more vertical, right? So at the very bottom, it says what happened to the graph as the slope increases. It becomes steeper. Again, steeper just means more inclined. Okay, coming back to the top of the page on the right side. Okay, now on these examples, I have a number that's less than 1. 0.5 is my slope. And you can see that my graph now became less steep. So it's not as inclined as the parent function. It's actually flatter, right? So kind of flatter, but we say less steep by a factor of 0.5. Okay, next graph that I have, the slope is 0.25. The graph is even flatter than the previous one, less steep by a factor of 0.25. So it's even flatter than the previous one because the number is smaller. This is 0.5. This is 0.25. Okay, my slope on this last one is 1/10. So if you're curious to see what that is as a decimal, that's 0.1. It's even smaller than the other numbers. So that's why my graph, it's even flatter. So less steep, we still say less steep by a factor of 1/10. Okay, so the smaller your number gets, the flatter the line becomes, which we call that less steep. Okay, so what happens to the slope when we decrease it? Well, it becomes less steep. Or flatter, if that helps you remember what that means. Okay, and then there's one more thing we have to talk about for the slope, which is on page 20. So if you notice now, my new equation, the blue line, the equation is a -1. My slope is -1. And if you notice, my graph looks very different. It's not going up anymore like the parent function. Now the blue line is going down. That's because the slope is negative. Whenever the slope is negative, the graph G, we say that it reflects over the x-axis. It's a reflection. It flipped it. It was going up, now it's going down. Reflects or flips the graph. That's anytime it's a negative. So it doesn't matter if it's a -10 or if it's a -0.8. If it's a negative number, it is going to flip it. Okay, so let's sum everything up on the bottom equation. So this is your formula for lines y equals mx plus b. Remember, m is the slope, b is the y-intercept. And so just summing everything up that we saw, remember if we change the y-intercept, if it's a plus number, it's going up. If it's a negative number, it's going down. For the slope, if it's a number greater than 1, like 2, 3, 4, 5, 10, 1,000, it's going to make your graph steeper. If it's a number that's less than 1, but greater than 0, meaning no negatives, it becomes less steep. Remember, the negative, what it does is it reflects it. So you could actually have a graph that's reflected, but also steeper. Okay, so greater than 1, steeper. Less than 1 with no negatives, less steep. And then if there is a negative, it's going to reflect it on top of whatever the number does to it. Okay, so I wanted to do 2 examples before you try some on your own. So 2 examples that are not in your packet. So number 1 says describe the change. So if you would like to do this without decimals, it's faster, but you really have to understand what the numbers are. So they're always going to give you the parent function, that's the first equation, and the new equation, and we're trying to describe how it changes. So remember, if the number has x with it, that's the slope. Slope can only do 2 things, make it steeper, or 3 things, make it steeper, less steep, or reflecting. So my number is greater than 5. So if I look at my chart, if a number is greater than 1, it's steeper. Sorry, greater than 1, so this makes the graph steeper. Now, this one describes the change. This is the parent function. This is the new equation. If the number that they give you doesn't have x, that's the y-intercept, the b. So we look at our little table. If it's positive, it goes up. If it's negative, it goes down. Well, my problem has a positive, so it's going to shift my graph up. Now, if this confuses you, if you find it hard deciding what change it creates, then all you have to do is graph the equations in decimals. Y equals x is the parent function. Y equals 5x is the second equation they gave me for the first example. And you can see that red line is a lot steeper than the black one, right? So steep, right? So even if you don't understand the part of looking in the numbers, then just graph them in decimals and see what happens. You can see it became steeper when you put it in decimals, right? You can see that. Okay, the second equation they gave me was x plus 6. So that's the parent function. Never erase the parent function. Then the second equation, x plus 6. This time you can see it's above the black one. It changed the y-intercept. It shifted up. So in this one, shifted up. Right, so when you're doing the practice, you can either look at the number to the side or graph it and just see what happens. So first you are doing page 22, 1 and 4. And then page 23, 5 and 9. You're going to pause this video. You're going to work on these 5 problems. And then you're going to continue with the video to finish the rest of the pages. All right, so you should have finished those 5 problems. So now in the second part of the video, we're just looking at page 21. It looks the same, but the equations look different. Right here, I have f of x, and then right here, I have 1 over 5 f of x. Well, you just have to know in this one for function notation is when we have f of x. The way it's written is different, but if the number you see, it's at the beginning of your equation, right after your equal, that's the slope. So that's m. And remember what we said, if it's a number less than 1, it makes it less steep, which you can see it from the graph, right? It's flatter, less steep. Ignore this, you don't have to do that. Okay, so same thing on this one, right? If a number it's after or at the end of your equation, then that's the y-intercept. And because it's negative, it should shift my graph down. But you can see it from the equation, right? It moved it down below the graph, the parent function. Again, ignore this. Okay, again, my blue equation, my slope is 5. If it's the first number before the f of x, it's the slope. And because it's greater than 1, it's steeper. But again, you can also see it from the graph. You can see that it's steeper. And then the last one, f of 3 is at the end. That's the y-intercept. It's positive, so it should shift it up. But again, if you don't know, you would graph both equations into decimals, and then you can see it's above the 0, so it shifted up. The only thing about this one's when you're typing them into decimals, you have to type the parent function first with the f of x, and then you have to type the second equation second with the f of x. If you don't type it that way, it won't graph it for you. Okay, so now that you know that this thing, f of x, is the exact same thing, you are going to finish the problems on page 22, 2 and 3, on page 23, 6, 7, and 8. Okay, so pages 22 and 23 should be completed by the end of today. And then you would work on your homework, the 4.7